All right, so this video is going to cover this 2012 AP Computer Science A question, number 4. I call it gray image. Again, this is all done in Java, so it looks a little bit funky here, but we're going to do it in C++ because, again, it's a good kind of challenging program for where we're at for studies in this semester. So it says a grayscale image is represented by a two-dimensional, rectangular array of pixels. A pixel is an integer value that represents a shade of gray. In this question, pixel values can be in the range from 0 through 255 inclusive. A black pixel is represented by 0 and a white pixel is represented by 255. The declaration of the gray image class is shown below. You'll write two unrelated methods of the gray image class. So we got a gray image class where we got a black integer value is 0 and a white integer value is 255. So we're going to have ourselves a pixel value 2D array that's an integer 2D array. We're going to have a count the white pixels and process the image. Alright, so write the method count white pixels that returns the number of pixels in the image that contain the value white. For example, assume that the pixel values contain the following image. A call to count white pixels pixel method would return 5 because there are 5 entries. So 255 is white, so it, when you're running this, you start at row 0 and then you go across the column. So there'd be 1, there'd be 2, there'd be 3, 4, and then down here is 5. So this is a pretty easy. A is really easy. You just do a nested for loop to run through the 2D array. Count white pixels. Alright, so let's get started on this using namespace. So there's only a couple things we're going to have to do here. Now I'm going to do it again. I'm going to do it a little bit different than what they're doing, but that's okay. So what will we do? Instead of, so you notice Java was final. We have const int, so that's for a constant where they don't change. So we'll make that black equals 0. Const int white equals 255. Alright, so then what are we going to do? I'm going to define my pixel values in here. I'm going to pass them. I'm not going to make it a global variable. So int pixel values. And since we know that there's 4 rows and 5 columns, I believe. That's what I counted before. I might be wrong, but let's go up here. 1, 2, 3, 4 columns. 1, 2, 3, or 4 rows. Yep, and 5 columns. So I'm going to shrink this down. And what do we got here? 255, 184, 178, 84, 129. Alright, 84, 255, 255, 130, 84, 78, 255, 0, 0, 78. right, so 84, 130, 255, 130, 84. So, and again, you don't have to line these up, but maybe it's best and easiest for you to see, you know, the columns lining up. I don't know, it just depends on. Either way, we got row 0, 1, 2, 3. So there's 4 rows. Column 0, 1, 2, 3, 4. So there's 5 columns. Okay. So next thing we want to do is to find the size of our rows and the row size and column size. So there are 4 rows and there's 5 columns, but we need to be able to put that in variables. So I'll say int row size, and that'll be equal to size of, so pixel values. Okay. And I spelled pixel values wrong. Okay. And then what? Size of, and then it would be pixel values at position 0. Okay. And then we're going to have int call size, and that's going to be equal to the size of, and I'm going to copy size of, alright, so that's how you'd find the number of rows and the number of columns in a two-dimensional array. Okay. So then we'll just do, this is going to be part A. So we will do count the number of white pixels. We'll say number of white pixels. And then we'll call the count white pixels. And we'll do an end L. Now I am going to, now in this one I don't think anything's passed to it, but I'm going to pass in those 3 things. So it's going to be a little different. So I'll do the int 4, 5, and then pixel, whoops, that's not right. Int pixel values 4, 5, and then I'm going to do the int row size and int row call size. Okay, and I'm going to copy that, define that up there, bam, right there. And we'll do a void. I gotta put void right here. So void that. Actually, it's not going to be void. We want the count, so it's going to be an int. We're going to return the count. Okay. Put count right there. All right. So then what? Return count. Okay, so we'll define it in here, int count. So then all we need to do is just do our for loops on this thing. So what we do, int row equals 0, row is less than the row size, row plus plus. So that would be 0 to 3, right? Because row size is going to give us 4. So 0, 1, 2, 3. It will process those 4 times. Okay. and then what, end call is equal to 0, call is less than the column size, call plus plus, and then if it's a white pixel, so if the pixel values at the row that we're in and the column that we're in are equal to the white variable, then we just simply count. Okay, so let's see here. What I got wrong with this? Got something messed up. What's going on? No, wait. Why am I doing this? I'm being stupid. They're already defined. I'm sorry. This is an easy fix. Okay. So you need to define them when they're coming into a new method. You don't define them when they're already defined up here. It's kind of duh. So row size, call size. So let's run this. We should get 5 here. Let's see if we get that. If I don't have any errors. Okay, failed to update. It says no issues found. Let's see, where's that at? Use an initialize memory count and oh, yeah, that's not an error. Let's do that. There we go, 5. All right, cool. So that's good. All right, cool. So that one's done. Part B. All right, so again, all we're doing for this, you know, we're just running through every single element in our two-dimensional array pixel values, and then just checking to see if wherever we're at in the row and the column, if that's equal to the white variable, then we add it all up. All right, so after watching a few of these array and 2D array values, you know, it's critical that you know how to run the for loops to run through each element in them, okay? And so that's that. So then let's check out what B says. All right, B says write the method process image. So we're going to do a function process image that modifies the image by changing the values in the instance variable pixel values according to the following description. The pixels in the image are processed one at a time in row major order. So we do row and then column. Okay. Call major order is we do column first and then we do each element in the row. So you actually go, if I was call major, I'd do 221, 84, 78, 84. Usually, for the most part, it's row major. Row major order processes the first. Okay, so it explains that. The first row in the array from left to right, and then processes the second row from left to right, continuing until all rows are processed from left to right. The first index of pixel values represents the row number, and the second index represents the column number. The pixel value at position row call is decreased by the value at position row plus 2 and call plus 2. All right, so if this is where I want to process, I got to go over 1, 2, and then down 1, 2. Okay, so it's doing something with this 0 right here. If such a position exists, if the result of the subtraction is less than the value black, the pixel is assigned the value of black. The pixel is assigned the value of black. The values of the pixels for which there is no position at row plus 2, call plus 2 remain unchanged. You may assume that all the original values of the array are within the range, black and white inclusive. The following diagram shows the contents of instance variables before and after. Okay, so let's look at this one. So 78 gets processed to 100. So 78 is 1 2 over. 178 is 1 2 over, and then 1 2 down is 78. So 178 minus 78 is 100. So we're taking wherever we're originally at, adding two columns and two rows, or two rows and then two columns, and then we're taking that value and subtracting them. Now, for instance, in column 3, and also so for all of column 3 and 4 and all of row 2 and 3, we can't, there's nothing past. So you go down here 1, there's nothing down here. That'd be out of bounds. So you don't process those. You would only process these in bold right here, because you can go over 2 and then subtract whatever value it finds. All right. So like this one, 84, 1 2, 1 2. So if we do 84 minus 255, that's less than the black value of 0. So we just assign this one to 0. Okay. So process image. So first thing I am going to do, because I'm not going to use, I guess I could use, I'm going to just use this one so we have the same data, all right? Okay, so I'm going to call this one, I don't know what I want to call it, pixel value B. I really don't care. I mean, I just, I'm going to actually copy this, the format, and just change, whatever I got. So I'll just paste it there. And I got 221, 184, 178, 84, 135, 84, 130, 255, 255, 84. So that row is the same. 78, 255, 0, 0, 78, 84, 130, 255, 130, 84. Okay, cool. So then what am I going to do? I am going to... I need to call my process image method. So since they're the same row and column size, I am going to reuse those variables though. So I could say process image, and I'm going to pass, and this is going to be called pixel values B. Let's say that. So pixel values B. Okay, we'll pass that in, and then we'll do the row size and the call size. Okay, so then we will, and then are we returning anything, or just, I think we're, let me see here, I think it's just going to be voided. Yeah, void. So there's nothing returned. So we will display it just to make sure, it's working properly. So let me go up here and put this in here. So we'll say it's void, and then we'll paste that. So we'll do pixel values. And then we could do void process image. Okay, so I need to do what my int, and this is going to be again for 5, and I actually need to do that. I gotta fix this. So int, so again, when it's being passed in, it's got to do that. So this will look better here in a second. Alright, that takes care of my errors. Alright, so again, we do our for loop stuff, and I'm gonna just copy, because again, we're running through all of them. I can just definitely copy. Okay, so right there, that ends there. Okay, so now watch this. So inside here, each time we'll create a new two new int values. So we'll say int other row equals the row that we're in plus 2, and int other call equals the call we're in plus 2. So this one's going to be our normal row wherever we're at, and this is going to be, you know, the row plus 2 and then the column plus 2, okay? So we need to make sure that they're not out of bounds. So we need to say if, and this will check that if they're not out of bounds, then run it. If other row is what, less than the row size, and the other call is less than the call size. Okay, as long as that's cool. Then we can actually process it. Again, the big error is we don't get out of bounds here. We don't go, you know, I can't do it right here and then try to find and pull information outside of the array because there's nothing there, and that will give you a compile error. Okay, so if it's less than the other row, or if the other row is less than the row size and the other column is less than the column size, then we will subtract the pixels out, all right? So we'll say pixel values B at the row and the column minus equals the pixel values B at other row and other column. Okay. Then our last thing in here, we'll say if the pixels value pixel values B, yeah, that's bad, values B at our row and our column, after we subtract them out, if that's less than black, meaning we get a negative number, then we just want to assign the pixels values at the row and the column equal to black, which would just be equaling it to 0. Okay, pixel values B. Okay, and what I can do inside this for loop is I can do a cout. Now this isn't required, but this is for testing purposes, okay? I would do my and I'll do a comma in there to separate them. And what, a semicolon. And then for each row, I definitely want to end it so it goes to the new row. End L. Alright, let's see. I think this is right. Let's look at this. And we'll know because I can then just... Wow, what's going on there? Getting some very messed up data there. That's funky. So 221, 184, 100, and then 0, 125, 176, but then this gets all messed up. So let's see where I'm making my mistake at. Row, other row. If the other row size and the other call is less than the call size, then we do our pixel values at row column minus equals the other row and other column. And then if, inside here, if the pixels at the row are less than black, it will be row is equal to black. So we set them equal. And then we do our row and column. And then end. Alright, let's see. I'll have to play with this a little bit. I think what I'm going to try doing, I'm actually going to try doing this before my if-else stuff and see what happens. So that's the original one, I believe. So let's look at this real quick. The original one, 221, 184, 178, 84, 135, 84. Okay, so that's the original. Okay, so other row, just be that. So this and that and that. Then we take whatever's here and subtract them out. I wonder if this is messing stuff up, because what we could do here instead, we could say if I don't know, I don't like this, but whatever, we could say if this, if this minus that is less than is greater than black, okay, then we can do this. Else. This might work. Let's try this. So if we subtract them out, if they're greater than black, then subtract them out. Assign them equal to here. Else, we just assign it to black. So let's check. How is it getting? Let's see. Okay. So we got the first three are correct. Then we get to 84. If other row is less than the size. The only thing I could think of is that the cout row size call size row size is 4, call size is 5. Okay. So if the other row let me think what's going on here. Oh, wait a second. Yeah, look at this. I only need 1. Let's see if this works. Gosh, if that was that, I wasted a lot of time. But again, it's not always the easiest thing debugging this stuff. Alright, let's build this again. Rebuild solution. Okay. Okay, so this I think looks a little bit better. Alright, let's hope this works because this video is getting long. So 221, A4 135, 0. Yep, that looks good. Oh, so yeah, that was brutal. I was sitting there trying to find. I didn't see it. I had a second less than symbol. So definitely don't want that. So anyway, you know, go ahead, try figuring that out. But this does work, and it would have worked the other way too if I just, you know, if I hadn't had that less than symbol. So anyway, this video is done.